Hello researcher, lovable welcome to Material Research Review. Today we are going to see Semiconductor Application Part 2. Uh, the title is Single Crystalline Indium Vanadium Oxide Nanosheet towards the promoting highly selective and efficient solar conversion of CO2 to carbon monoxide. This article published recently in JAX. Professor Xinghang Zhou, Nansing University in China. What is the highlight of this work? The indium vanadium oxide 110 surface nanosheet. It can decrease the recombination and the change of the electron and hole into the body cell. Uh, and another one highlight of this paper, the CO2 reduction reaction selectively selective product formation of carbon monoxide. So this were 2 point only in this paper the highlight. First of all, how this for the synthesis procedure, like the indium vanadium pentoxide nanosheet, they used sodium orthovanadate dissolved in water until the clear solution coming. After that, the indium chloride also dissolved in distilled water. Both mixed and stirred. Some yellow color precipitation came. After that one, they used the adjust the pH 1 to 2 using nitric acid. After that, they transfer into 180-degree autoclave for 18 hours. After they washed and collect the product, that one for indium vanadium pentoxide nanosheet. After the comparison purpose, they synthesize for indium vanadium oxide nanocube, and this also equal mole and same condition they did. Here only they did for the sodium hydroxide used the pH maintained for 5. Previously that vanadium nanosheet, indium vanadium oxide nanosheet, they use the pH 1 to 2, but in the nanocube just adjust the base. Is also pH 5 they maintain, but using the sodium hydroxide. So here it will form the nanocube. And one more material also they prepared, like a bulk material, indium vanadium oxide, using the indium oxide powder and vanadium pentoxide powder, both mixed and high temperature they used to 800 degree for these three material they compared to the catalytic reaction. After how the characterization for this one, initially the indium vanadium nanosheet characterizes the XRD, the XRD peak showing that 110 they observed high intensity compared than that 112 peak. The intensity ratio both is 110 is more high. They compared with the CPDF value. The CPD value also not observed the high intensity peak of 110. So they said that special anisotropic growth along the 110 plane. They mentioned like that. And this also, here also they observed that reflection, the small angle, also the 001 reflection peak they observed. This one, like they said, this is the layer structure peak, like that they said, like Lambert structure peak. That one they got uh, the 2 theta is around 6.23. They got that small angle peak. The d spacing also they calculate 1.41 nanometer. After They both the three material also they compared with XRD, like indium vanadium pentoxide nanocube and bulk material. After they took SEM image, low mag high mag, they took, and TM also low mag high mag they did. After that 110 facet crystalline model, the nanosheet also they compare with TM image, both they compare with the model. And after that they run the UV visible NAR, sorry, UV visible absorption spectrum. Here the 300 to 450 the broad absorption peak they got, and they calculate with band gap for indium vanadium oxide sheet showing the 2.3 electron volt band gap. After they, and AFM also they did from the AFM, that seed thickness they got the height plot showing 1.5 nanometer thickness. If singles seed size also they got 1 point, and 3 seed size also they got 1.5 average size. So this this that edge and that small angle peak matched both they saying. After they jump into the application, here the uh, selectively got the carbon dioxide to carbon monoxide product. Initially the water evaporation, and after the CO2 two electron two proton reaction process, it will form CO and H2O. This is the main product, and side, and another like a secondary product also they got 8 electron and 8 proton reaction with the CO2. They got methane and methane and H2O. They got, they compared with the three material indium vanadium oxide nanosheet and indium vanadium oxide nanocube and indium vanadium oxide bulk material. Compare then 100 phase and 11, and 110 is more efficiently and the selective CO in the product formation. And they compare with the methane also they got for the secondary product, that also that nanosheet size is also showing more compared than nanocube and bulk material. That plot only they clearly they put here. One drawback I observed, I will tell for later. mm, After the quantum yield quantum yield, the CO evaluation of that indium vanadium oxide nanosheet, they got 0.54 percentage at the wavelength 385 nanometer using monochromate light. After that the application they got, that one they clearly why they got selective yield, that one through the charge recombination. They proved some experiment. They used to initially surface photovoltaic spectroscopy for the study charge carrier separation and transport behavior under the light irradiation and the dark. They both compared. Here you can see the image, the potential image under the light and dark. In the dark condition, the sun showing the brightness. After the light irradiation, they got the indium vanadium nanosheet got the very brightness that the seat they marked, and that all seat side in the showing the very brightness. But in this case of nano indium vanadium oxide nanocube side not got. mm, and also that bulk material also not getting the brightness. So that selectively that 110 is showing the charge suppression is the less distance. After that they compared with the another plot like a lifetime measurement they did. Here both compared the lowest lifetime um, photoluminescence lifetime they measured the value is like 1.2 nanosecond they said, but here also one drawback there I will show you later. Mm, After that they did EPR study. EPR study also compare the nanocube and bulk that nanosheet only showing the uh, superoxide peak using the tempo. Some intermediate product they observed the in suit method they used and they measured the FTR spectrum for the nanosheet side dark and light irradiation. After light irradiation they got that COOH intermediate peak, but another nanocube side and bulk material doesn't show the COOH intermediate peak. And after that they uh, did electrochemical photocurrents responsible electrochemical measurement photocurrent response. Mm. They used the three material compare the two that nanosheet only showing the good current response. The light on off both they did for the uh, 30 seconds. Here compare the all that indium vanadium pentoxide nanosheet only showing the good, and electrochemical impedance spectrum also they run. Compare the two material, this one only showing the better efficiency. After that they did one uh, for the thermodynamic process the CO2 reduction to CO formation. They did density function theory. Here this image only maybe the reviewer just will see the image they are accepting in this paper, because that much drawback are there in this paper. This paper like they looking that image only they accepting maybe this article. The that theoretical calculation also they did, and gives free energy profile also showing the carbon dioxide reduction reaction into carbon monoxide formation. Both they compared 110 and 1001. After that they mention only for the highlight the 2 point only they here they explain both like the decreasing the recombination and for the that seed side that 110 surface side. compare than other, this one best material they said. And CO2 reduction on the selectively they got CO mm, first product, main product they got CO, and secondary product they like methane they got. That mechanism only, that theoretic calculation they did. This only this highlight of this work. What are the drawbacks I observed? Uh, Initially, that XRD, usually the nanomaterial per the cubic pace, 200 peak, it will showing high intensity compared than all that one only nanocube. But in this case, they cannot observe the cube peak from the XRD pattern. They compare 3 XRD, but 200 peak intensity uh, similar only they got. Compare than that bulk material showing the high intensity, but that nanocube side not showing the intensity of 200. If going to next the SEM image, uh, that one the indium vanadium oxide nanosheet showing very clear ACM image, low mag, high mag, but in the nanocube side they cannot clear the structure. ACM and ACM just one single particle they took, and other low mag means they cannot cube observed. uh, and the TM image also, that one not like cube, they just said cube. But why this one accept for the reviewer, I don't know. And another drawback, the intermediate observed COO for the FTR spectrum. But in the result, the CO2 conversion cube also they got some yield, but here the FTR spectrum not observed in the COO intermediate, COOH intermediate, and EPR also only that indium vanadium oxide nanosheet only it's showing the superoxide, but not showing other nanocube and bulk material. So if not showing the nanocube means how they will get the CO2 and methane yield for nanocube. This one big drawback. This also why not observe the reviewer, we don't know. Mm, and after that they, if both comparison means same scale need to maintain. For example, they got the CO2 150 micromole gram micromole per gram they got, means that nanocube also that secondary product like methane also same scale but need to compare, but both are only the highlight they compare. But this looking like the methane product coming more like that swaying. So this one small mistake for comparison purpose. And for the photoluminescence spectrum, only the noise peak only they got. That noise peak, how they explain for the, they got 1.25 nanosecond and the lifetime they mentioned. This is the lowest lifetime. This one not that spectrum not matched, because only the noise peak absorbed both the three material only noise peak, but how they that nice big they explain this one don't know. This is one big drawback for the lifetime measurement. But the experiment data and the application data both are not matched. What they got yield, what they explained, both are not matched. This is the overall the this paper drawbacks. And the future possibility work, they said that 110 indium vanadium pentoxide, the very less decreasing the charge recombination. This is the key point. This one only the if any other application possible like photocatalyst already they did but not clear comparison. If compare with some other photocatalytic reaction means it will good, but when the compare means all data need to clearly explain. Thank you for your kind attention to watching this video. Welcome to your valuable comment. Thank you.